In 1950, over lunch at the Los Alamos National Laboratory, physicist Enrico Fermi asked his colleagues a famously simple question: where is everybody? Fermi wasn't necessarily denying that aliens existed. He was questioning the feasibility of interstellar travel, calculating whether the sheer physical distances of the galaxy could ever be bridged. That skepticism took a more rigid turn in 1975, when astrophysicist Michael Hart reframed the question into a formal scientific ultimatum: they are not here, therefore they do not exist. This shift in perspective birthed what we now call the Fermi Paradox, turning the empty sky into a cosmic missing persons case that has haunted science for decades. The observable universe contains billions of galaxies, filled with star systems that formed billions of years before our own. Scientists use the Drake equation to navigate this scale, treating the galaxy like a lottery where millions of potential worlds are filtered through the variables required for life and intelligence to emerge. If a civilization survives that lottery, the Kardashev scale suggests they should eventually become impossible to miss, building galaxy-spanning structures to harness the energy of entire stars. This creates a profound tension. If the math suggests that ancient, visible empires should be common, then why are we met with such a total, absolute silence? The most prominent explanation is the Great Filter, the idea that a specific, highly improbable evolutionary leap stops almost every species from becoming a spacefaring civilization. The rare Earth hypothesis suggests we are the exception to this rule because the filter is already behind us. This Monte Carlo simulation outlines why Earth might be a statistical anomaly. A world requires a precise solar mass, a stabilizing moon, and a massive outer planet like Jupiter to act as a celestial shield against asteroid impacts. If these conditions are as rare as the data implies, the universe isn't a graveyard, it's simply barren, and we are the first intelligence to reach this stage. But there is a darker possibility. The filter isn't in our past, it is a trap waiting in our future. The traits that drove our evolution, competition and aggression, may become fatal once a species achieves the capacity for planetary destruction. We already have evidence of this technological bottleneck in our own history, having developed planet-altering weapons long before we mastered the means to leave our world behind. If every civilization inevitably collapses under the weight of its own power, the galaxy will remain silent forever. Other theories suggest that aliens exist, but they are hiding. The dark forest hypothesis portrays the universe as a predatory environment where revealing your location is an invitation to extinction. In this model, the only logical survival strategy is absolute radio-silent isolation. Alternatively, the zoo hypothesis suggests advanced beings are peacefully observing us from a distance, much like a nature preserve. But philosopher Nick Bostrom notes that this assumes perfect galaxy-wide conformity. After all, it only takes one expansionist civilization to break the rules of the zoo and make themselves known. Because biological evolution is inherently chaotic, relying on every single alien species to follow the same protocol is statistically improbable. We must also consider that the silence is an illusion, a result of our own primitive detection methods. A civilization's period of emitting loud, detectable radio waves might be incredibly short. Advanced species likely transition quickly to quiet, efficient technologies like nanobots or narrow-beam lasers that evade our telescopes. Our own physical reach is still in its infancy. Probes like Voyager have been traveling for nearly half a century and have barely scratched the outermost edge of our own system. We might be completely surrounded by life, yet lack the tools and the perspective to recognize the signals for what they are. This brings us to a terrifying paradox. Our best hope for a future is to find absolutely nothing in our own solar system. If we discover that life sparked independently on a moon like Europa, it proves that the transition from dead matter to biology is easy. That would mean the Great Filter must lie ahead of us. Finding ancient fossils on nearby planets would suggest that some universal mechanism inevitably destroys life before it can reach the stars. For humanity, the most hopeful discovery we could make is a dead, lifeless universe. It would suggest that the hardest obstacle is already in our past. The Fermi Paradox reflects our deepest anxieties about evolution, technology, and our own survival. Our current astronomical search covers only a minute fraction of the vast, ancient, and indifferent space surrounding us. This silence places a heavy significance on our own fragile Earth. Whether the universe is truly empty or filled with civilizations that have learned to stay quiet, the fact remains: our existence is an incredibly rare and precious event.